Bluetooth was hooked on. Like, it just plays like whatever was playing on my phone. It was on the speakers, you know. And someone made a comment on one of my videos, so I replied to it. And my voice started, like my lecture started playing in my car over my. Freaked me. It was like the weirdest thing. All right, what do we got? You said you're confused. Where we at? Where at? On the second part? Okay. 28 on the second part. Let's look there first. So this one's tricky because, but actually, I bet you if the graph weren't there, more people would have gotten it right. But every question so far, you've just been able to kind of look at the graph and go from there. This one, it's pretty tough to look at the graph because, so this is pi over 2, this is pi over 4, and then pi over, so that's like 45, pi over 6 is 30, so it's like here, and if you try to read down to the graph, you're kind of like in this, I don't really know, you're in this estimating place. That's not really what you want to do, but the reason we had to use the graph in all the other ones, most of the other ones, is because when you plug in, you get 0 over 0. So like in almost every graph, I think, I didn't look at them all, but if you just tried to plug in and do it algebraically, you get 0 over 0. So they're like, okay, you can't do it that way, here's a graph. Well, this one you can plug in. That's what I mean by if the graph weren't there, my guess is more people would have gotten it right. But you can just, and I'm not really going to take the time to go through it, I'm not that concerned about the plug-in process right now. But if you just put pi over 6 here and work that out, you would get a number, and that number would be your answer. You wouldn't get 0 over 0. You wouldn't be screwed and stuck and have to try some other method. You would just get a number. And like if you want to work through the number, and if you don't get it, let me know. We can try to figure it out. I'm not going to do it like in front of everybody, but is that fair enough for that one? And what other one? Oh, okay. Did not realize this was on here. This is a little bit ahead of where we would be. So I'm trying to decide if I should just wait until we get to it or go through it now. Let's just talk through it. It's not going to hurt. So limits at infinity are horizontal asymptotes. Horizontal asymptotes, when you get that horizontal dotted line, then it's going to like level off on either side. And so looking at this graph, I'm guessing a bunch of people put like 1. Like, did you want to say 1? Very reasonable answer looking at the graph. Again, you'd probably be better out if the graph went there. But I would put 1 if I just looked at the graph too. If I go back and look at the question, the way you figure out if the limit is infinity is you first you look at the biggest power at the top and the bottom, and you simplify it. And then we're going to do something after that. But if I just look at this, what's the square root of 4x squared? 2x. The 3 doesn't matter, because when I start plugging in gigantic numbers like 10 trillion, plus 3, just it's like, who cares? What's the square root of 3x squared? Well, it would be the square root of 3 times x. And then what you do, well, imagine plugging in some gigantic number into this, like plug in 10 trillion or whatever. You're going to plug it in there and there, so what's going to happen to those? They're cancel out, and this is your answer. Is 2 over the square root of 3, which they probably simplified and said that's 2 times the square root of 3 over 3. And if you do 2 over 3, if you turn that into a decimal, I think it's like it's like 1 point. It's somewhere near 1, which is why it looks like it's going toward 1. And you don't learn that. You're not responsible for that. I'm just kind of talking through what we're going to do in a couple days. Is that okay for that one? Other ones? Alright, so let's look at the back then, see how that went. We didn't have answers to these. So I'm just going to go through and do it, and that'll be how we check. Okay, so limit as x goes to negative infinity. So that means my x value, I'm going like as far this way as I possibly can, and I want to see what y value. My graph is kind of leveling off, if it's leveling off, or if it's going like up forever, down forever. As I go to the left forever here, it is leveling off. It's leveling off at a y value of 1. It will never be 1, but it's like approaching, it's, it'll be 1.01, 1.001, 1.000, Limit as I approach -4 from the left. So -4 is here. The negative means I'm going to jump just to the left of the -4, find the graph, and start cruising back toward -4. And that is going up forever. So infinity. -4 from the positive direction. That's just the opposite side. So positive direction, remember positive and negative. So you go just to the right of the -4, you find the graph, and you start kind of going back toward -4 and see what the y value is doing. It's going up forever. So then because these two are the same, your limit as x approaches -4 is also the same. If these two were different, what would this be? Like if this were positive negative infinity and this were negative infinity, what would I put here? Does that exist? It's got to be the same for both sides. As x approaches -2, what does it look like my y value is going toward? So if I come from this side and this side, it looks like my y value is heading toward 1. The value is in a different spot, but like we talked about yesterday, does it matter if this point is there or where it is? This point has nothing to do with the limit. I could slide it inside that circle, I could slide it up here, I could remove it. It doesn't matter. It's just like where we look like we're going. We actually don't really know or care what happens when we get there, just like when we're almost there. F of -2 is okay, now where's the dot? What's the y value when x is -2? And that's it. Something else I'd like to point out here too, so a common misconception is that there cannot be points on an asymptote. That's true on a vertical asymptote. So I can't have a point on a vertical asymptote because if I plug in x, there's just not going to be a number. But I can have a point on a horizontal asymptote. So like this horizontal asymptote's at 1, right? Well, I put a point there. I could have put a point there. I could cross over it as many times as I want. A horizontal asymptote only matters at 2 spots. What are those 2 spots? The only time it has to level off is at 2 spots. Positive, negative, infinity. So I can cross over it a billion times, as long as by the time I get over to infinity and negative infinity, it's leveling off. It can still be an asymptote. So you are allowed to touch horizontal asymptotes as many times as you want to, need to, whatever. Questions yet? Top half here. Okay. As x approaches -1 from the left, so -1 from the left-hand side, my y value is going to 0. -1 from the right-hand side, my y value is going to -1. So that -1 in general does not exist because it was different from each side. The roads didn't come together. Then we go to 1, so from the left to right and then overall. So at 1 from the left-hand side, the y value is -1. We're approaching -1. 1 from the right-hand side, the y value is approaching -2. So then 1 in general does not exist because these are different because your roads didn't meet, they didn't come together. At x equals 2, so I can't really show that sign the scroll back yet.
Isn't the limit as x approaches 1 from the right hand of 3?
Oh yeah, there's a dash, there's a thing there, isn't there? Yeah, thank you. That's -3. I covered up my own work. You couldn't even see what I was doing. I covered that up. Okay. At 2, so what's the limit as x approaches 2? 0. What is f of 2? 1. So f of 2 is what's the y value of the actual dot. So this is 0, this is 1. Let me ask you this. Is the function continuous at x equals 2? We talked about this a little bit yesterday. Continuous would mean that these two answers, the limit and the value, are the same. And they're not here, so that wouldn't be continuous. As x approaches 3, what's my limit? So what's the graph? What are the y values doing from both sides as x approaches 3? Going down forever, so that's -infinity. And then this kind of got cut off, but you can kind of read it. It says as x goes to infinity. And that's supposed to be leveling off here. So that's supposed to be 1 also. So I'm trying to show the graph and the answers. Any of those I can go over. How many got them? Let's say all of them are just missed like 1 or 2. Like you did pretty well. Okay, cool. So you can see like this 21 down here. This is a test one of the years. there's 21 points on this page, which seems high. I don't know. But this could, the point I'm trying to make is this could very easily be like a page on one of these on the next test. So questions on there at all? So we talk about the 7-second thing here. So when I ask if there's questions, the research says I'm supposed to wait 7 seconds. Just watch how it like log it off. Any questions? That's 7 seconds. Like, that's so cool. Alright, so I just made another one. I wasn't really sure how it would go, so I made another one to practice. And then we're going to try to do it backwards, which is a lot more interesting. So I'll give you like the bottom half, and you'll have to make the graph.
Oh, okay. That's not bad.
This one. So is that typical way to do this?
So, we had to go a different route. I wanted to be here earlier.
Oh, so today was like an exception. I mean, it is what it is. I'm not bad at it. Starting to figure out.
Yeah, like, I don't know, because, like, the roads were closed, that's why. So,
So work on this by yourself. Like if I give you work to do, I don't care how you do it. By yourself, with a partner, with a group, with your notes, without, whatever. It's whatever, however you learn best. You know, everyone's kind of different that way. I'm going to go around and tell you a letter. You are responsible to put the answer to that letter on that sheet of paper. A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. So there's a pen up here. Whenever you're ready, go put your hands up there. Some people are going to get wrong, and it's fine. That's not the point. The point is, like, let's see if there's mistakes, and if there are, let's try to fix them. No one's even going to remember who put what, you know. So. Make sure you do the rest of the worksheet too. Don't spend 10 minutes on your own part C or whatever. You got the stuff, right? Yeah, I'm okay.
And then there were less people, so that was
Why did I get those two?
I do my own thing.
He didn't care. Such a rebel. First thing I think of when I think of Dale is rebel. Oh, we're not done yet.
It's negative, so it's about 16.
Oh yeah, we are. I don't think. Alright, these are all right. Every answer up here is correct. So go. Well, are we done yet, or should I? How many are still working on it? Okay, so go ahead and check them. I didn't mean to rush you. Got a little excited there. So those are all correct. So if you got a question on, if you got something different and you don't know why, let me know. Questions on this at all? Alright, let's try it backwards. It's a little tougher. So I just made a graph right here that you can't see, obviously. I'm going to put the information and like the answers to that graph, kind of the details, on this sheet of paper, and your job is to try to make the graph that I made. Or something close to it. It doesn't actually have to be exact. There's your characteristics of the graph. And you are supposed to try to make the graph. This is a little tougher. So you got to think about what all these things mean. Probably do a couple of these. I spent the rest of the class on that. either spot, that's an asymptote. Just gotta figure out kind of which is which. lines again. It's like, oh yeah, this is a whole other level. I think I'm gonna say third and try. I'm gonna say, oh, yeah. I know. Yeah, he said higher R and so I think we'll start taking this one of our last courses. How we doing? This is tough, especially the first time you see it. Do you want some more time, or good if I start going through? Go ahead. All right. At some point, time doesn't really help. Kind of know what you know. So, if I'm going all the way to the left on the graph, like if my x value is going to negative infinity, and we're leveling off at a y value of 3, what does that tell me I need to put on my graph? That's a horizontal asymptote. So that's the first thing I would do is just go, okay, horizontal asymptote of 3, so that was done. Any other infinities I'm going to look at first, so let's just go to this one. X approaches negative 2. Now that's the y value. Remember, limits are y values. So if the y value is going up forever, what does that mean has to be on my graph? Vertical asymptote. So at negative 2, I've got a vertical, and I'm going to skip all that and just jump to here. This means as I go to the right forever, I also go up forever. So at the very end of my graph, I'm going to have something like that, where when it's going at that angle like that, now it's going to the right forever and up forever. There's no asymptote there. It's not leveling off. It's just we're going up and to the right, just to the moon. Question on those three, like the infinity parts. That's the asymptotes. That's the first thing I would throw on. Then I would look for like actual dots, like actual points to put on your graph. So f of 0 equals 1. Well, that's a point. That's an actual dot that goes at 0, 1. 2, negative 1, that's an actual dot that goes at 2, negative 1. And now I've got just this limit stuff to worry about, which is the hardest part, right? But questions on what I've done so far. Alright, so as I go to an x value of negative 1, the y value needs to be approaching 1. And I didn't clarify if it actually is 1 at that spot or if it's not, so you kind of had a choice. But there's no reason you couldn't just go, okay, negative 1, 1. There's a dot there. You could have made it an open circle if you wanted to, because I just said the limit has to be a y value of 1. I didn't say like the value has to be 1. But you could just make it a closed circle also, so you kind of, it's up to you there. I should go back here too. With this vertical asymptote, I think I would do this. Just to kind of remind myself, okay, I know it's coming from both sides and going up forever, and I'm going to have to connect it to something. Remember when you're connecting, you can't go like back and forth. Do you guys know the vertical line test? So if a vertical line hits 2 points, it's not a function anymore. This has to be a function, so you can't ever like circle back. I don't know if anybody tried that, but a lot of times I see people try to like make the way people try to connect these gets interesting, which is fair. It's hard at first, so I'm done with that. Okay, now as I go to 0, as I approach an x value of 0 from the left, the y value needs to head towards 0. Well, if I'm coming at 0 from the left, I'm coming from this point, really. So if I come towards 0 from the left, my y value needs to be going to 0 also. Now, can I put a closed dot there? I can't, because that would break that vertical line test, right? So this has got to be an open circle. So that's kind of the first like connecting piece that I have there. What time is this class over? 27, 28, 26, around there? Okay. As I come to 0 from the right, my y value is heading toward 1. Well, coming from the right, aren't I coming from this point? So coming from the right-hand side towards an x value of 0, my y value needs to be 1. Well, there's a point there too, so I'm really just connecting those. And then that fits those qualifications. 0 from the left, I'm going toward a y value of 0. And 0 from the right, I'm going towards a y value of 1. Now there's only one more thing, so the limit as x approaches... Oh boy, we got an issue. I didn't realize I did this. As x approaches 2, my y value is actually 0, so I should not have connected those. Let me do it, I'll show you why. So if the limit as x approaches 2 is 0, that means the y value has to be heading toward there. And I just got a little ahead of myself and went down there. But so what we got going on here is, if I look at these two together, the limit as I approach 2 is 0, so from both sides the road is heading towards 0, but the actual value when x is 2 is down here. So this part shouldn't be here. Sorry about that. Question on that part I just did? I kind of screwed that up, but that's okay. See, watch me fix it too. And then I'm just connecting stuff. Connect that to that. Connect this down here. And then this has to level off at 3 as I go to the left forever. So I get something that looks like that. If anybody has something reasonably close to that? Cool questions I can help with. Where'd you get this? I don't see why this happened. What's going on here? Okay. Wait, let's do it again. Make up another graph. Again, I would probably start with asymptotes, and then actual points, and then try to work the limits in there after. another minute or so. It's not really time to go through it before you leave. Too. Alright, so as I approach negative infinity, as the x value approaches negative infinity, my y value needs to level off at negative 2. That means there's going to be a horizontal asymptote at negative 2. You've actually got the same horizontal asymptote on the other side, so as x goes to infinity, you're also going to level off at negative 2. How many horizontal asymptotes could there be? What's the most that are possible? Why? Where are horizontal asymptotes relevant? Positive and negative infinity. So how many could there be? There could be 2. There couldn't be 3. It could do something. It could level off on one side. It might level off at a different spot on the other side. But there couldn't be any more than that. There's no other sides to level off. There could be 0. There could be 1. There could be 2. How many vertical asymptotes could there be? You guys know what the graph and tangent looks like? Where it's like that wiggle and then vertical asymptote, the wiggle and vertical asymptote, and the wiggle and vertical asymptote, like forever. So vertical asymptotes are unlimited. But horizontal, they only count all the way over here, all the way over here, and there's only 2 directions, so there can only be 2. I got my vertical asymptotes on here too, so this, as I go to negative 3 from the left, then I'm going up to infinity. As I go to negative 3 from the right, I'm going down to negative infinity. As I go to 4, I'm going to negative infinity from both sides. Put my points on there too, so f of 0 is 0, that's a point right there. F of 1 is 0, that's a point right there. Right, I'm going to hit that part before we get to the limits. Okay, and then it gets, that's good right there. Then it gets tougher to do the limit part. Alright, so at 0, as I approach, so I got my point there, but that doesn't really have to do with the limits. As I approach 0 from the left, the y value is going to negative 1. So from the left-hand side, I need to be, and it could be, you don't have to go up toward that point, you could go down. Like, you just have to have something coming off of that point going to the left. And what it's going to do is connect to this. And you could connect a little differently. You know, like if you decided you were going to connect it like that, that's fine. If you decided you were going to connect it like this, that's fine. Just don't go like backwards over yourself. As I approach 0 from the right, we're going toward a y value of 0. So again, you could do it from the bottom or from the top. I'm going to do that. I'm just going to kind of wait and see what happens because I learned last time. And then the only thing left is, as I approach 1, the limit needs to be 1. So am I going to connect to this point? I'm not going to connect to this point because this is at 0. So the limit needs to be 1. And if I didn't tell you right or left, that means it's the same for both sides, right? So it's got to meet. So this has to kind of go up and then do that. So the roads have to meet at a y value of 1 above x equals 1. And then I'm basically done. I got to connect stuff, but like all this stuff is on there. So here, when I connect it, I'm connecting it to like this horizontal asymptote. So you just gotta draw that down and make it level off. This part's connected, this part's connected. Here I'm gonna connect these two pieces. And you might connect them a little differently than that, and that's okay as long as you didn't go like backtrack over yourself. And then again, this has to level off. And you could actually, like, is it okay if I go over it and then come back down? Sure. If you just go straight to it, that's fine. If you go up and down a bunch of times and wiggle, that's fine. As long as when you get to positive infinity, it starts to level, then you're okay. How many have this or something, similar that you think is also correct or close? Let's do that. Other questions I can help with? Why are you rolling your eyes at me, Laura? All right, no homework.